So, in our previous part, we understood about vector planes. Vector planes. Before that, we discussed about vector lines. So, let me draw a plane like this, and let me draw a line like this. Now, planes are defined by pi. Lines are defined by L. So, we have to know this picture precisely. If you want to define a line, there should be a point on the plane. There should be a point on the plane. And origin is somewhere here. So we are going to look at a point on the line from the origin, and that is called R of lambda. Now we know this point. I would say 1, 1, 1, for example. Also, we need to have a vector which is parallel with this line. A vector which is parallel with this line. If you have that, we define our R of lambda like A plus lambda d. Now, A means the vector from O to A. Now, this A vector is known. Also, this D vector is known. Right. So, this is how we do it. Now, we understood when you change lambda value, you are changing this point. You are changing lambda, you are bringing this point to here, or maybe to here. So, that is when you are changing lambda. When it comes to plane, you have to have a normal vector to that plane. We call it n vector. Right? So this is how we give a directional sense to a plane. I used this word in the previous session as well. Directional sense. How to give a directional sense to a plane. We give that in a perpendicular direction. Now, you have to have a point here. You have to have a point here. That point also a defined point. Right? And you have a point over here. That's it. That is an arbitrary point. Means that point can change. So the coordinate of this point is x1, y, and z. Coordinate of this point is a, a1, a2, a3. That's a known point. Right? Now, this is the picture we should have. I would say this point to be R, and that's the arbitrary point. Now, you have to understand why we are going to take an arbitrary point is because we need to make a plane equation. Equations are like this. Equations have variables x and y. So you have to incorporate variables x and y and z. That's why you have an arbitrary point here. Now, once you do the calculation, which I'm not going to show in this session, in the previous session we did that, this would be r dot n vector is equal to a dot n vector. Okay. R dot n vector is equal to a dot n vector. This is the vector equation of a plane, vector equation. Now, if you simplify these vectors using dot product, then you get Cartesian equation. So then you have two types of equations, Cartesian equation and the vector equation of the plane. right? Or if I write this one, the same thing in this way, is it a big problem to you? R dot n hat is equal to A dot n hat. Is it a big problem? Reason, the first equation you can divide by n vector magnitude. And this side you can divide by n vector magnitude. So it's an equation you can legitimately do this. When you do that, n vector divided by n vector magnitude becomes this guy. So summary would be this and this both will work. Both gives you the vector plane. Yeah, that's it. Okay. Now this is the summary of our previous session. Right. Let's think about this now. I'm going to have a plane like this, and this is my z-axis, x and y like this. So this is my x, this is my y, this is my z, right? So I'm going to get a point here. I'm going to get a point here. Tell me that point. I'm going to get this point here. This point can be x1, y1, z value 5. Okay. Now, what would be my normal vector now? K hat. My normal vector is k hat. Now, why my normal vector is k hat? Due to my construction. I construct my plane to be like this. Right? Now, I'm going to have another plane. I'm going to have another plane like this. I'm going to have another plane like this. And I'm going to take this point over here, which is very much vertically up point. That point I'm going to get 1, 1, 9. Agree? Because that point is in the changing in the z direction only. What would be my n hat now? My n hat becomes k hat now. My n hat becomes k hat. Okay. Now, I'm going to find out the vector equation, right, of this guy. That would be r dot n is equal to a dot n. Now, r is going to be xyz. So I'm going to do in this way, xyz. For simplicity, I'm going to use this bracket notation which we used last time. N is going to be what? Dot with k hat. Now, A is going to be 1, 1, 5. Then n hat is going to be k hat. Right? So now k hat, if you want, you can write 0, 0, 1 in the bracket notation. You can see at the kth place, the z component is going to be 1. Right? So similarly, if you want this one, you can write as 0, 0, 1. That's how you use the k, which is the z value. Now, when you do the dot product, what you're going to get? When you are doing the dot product, you get z is what you get from the left hand side is equal to, from the right hand side, what you're going to get is 5. Z is equal to 5. Right? Now, writing the plane equation is this way, we call it vector equation of the plane, because vectorially you wrote it. But when you simplify that, you get the scale equation, which is the Cartesian equation. And that would be z is equal to 5. So what is z is equal to 5? Z is equal to 5 is the Cartesian equation of that plane. That makes sense. Why? Because when you have this plane is z is equal to 5. That's the Cartesian equation of that plane. Okay. Z is equal to 5. Okay. So if you do a similar calculation here, you are going to get z is equal to 9. K hat is 0i plus 0j plus 1 k hat, which is going to be 0, 0, 1. Okay. Now, why we have this diagram? Why we have this diagram? Reason is this. Why we have this diagram? First of all, if you take this plane, r dot n is equal to a dot n is my vector equation of the plane, then this a dot n guy is going to be 5. That was 5. When you get this guy, for that guy also, this a dot n guy is going to be 9. Right? Now you have to understand and summarize. What is this a dot n hat and what that a dot n hat is doing? This a dot n hat is the amount which is translated from the origin. This is the origin, right? So if you make a line like this, here is 90, right? So this amount is 5. Here, make a line perpendicular to the surface. Then this is 9. So that a dot n simply tells you how much the plane is deviating from the origin. Right? So same plane, you can bring up, down. You can bring up, down by manipulating a dot n hat term. That I proved to you. I showed you with an example. Example. Think about a plane like this. And this same plane is translated parallelly What I'm saying is this is parallel to this. So your origin is here. Suppose your Cartesian system looks like this. Suppose your Cartesian system looks like this. Then here you get n vector. So you get the same n vector here. Why? Because it's a parallel transformation, same n vector. Same n vector. Now, if you make a line like this, which is perpendicular to this surface, this is your A dot n vector, or maybe you can say A dot n hat. I'm going to take this equation to be 4x minus y plus z is equal to 3. I'm going to get this one to be 4x minus y plus z to be 8. Right? Now it should be like that. Why? Because left-hand side should be the same. Why? Because they are parallelly moving. Now, from these details, you are going to extract your n vector, which is going to be 4i minus 1j plus 1k. From here, you are going to extract your n vector, 4i minus j plus k. Same n vector, you can see the direction of the n vector is the same. Now, we have to understand what is the meaning of this 8 and this 3. So 3 means this distance. Then what would be the shortest distance? What would be the shortest distance between two planes? 8 minus 3, 5. 8 is the distance from the origin to the plane. So the distance is going to be that. So this concept will come in questions in a different way. In a different way. We'll discuss that in a minute. Plane rotation. So rotation can be about 3 different axes. Rotation can be about x-axis, can be y-axis, can be z-axis. For now, I take the rotation about x-axis. Rotation about x-axis. So I need to create the Cartesian system for it. So Cartesian system would be z is here. I'm going to put my x here and y is here. Now, I'm going to have a plane like this. I'm going to have a plane like this. And this plane is going to be phi 1. Then I'm going to have another plane here. Actually, not another plane. The same plane is rotated. It is rotated this much, theta angle. Right? Theta angle, it is rotated. Now, when it is rotated, your plane would be pi 2. It becomes a different plane now. Right? Now, I'm going to have a point here. Now, how do you define a plane? You have to have a point here. I would say A. Then you have to have another point here, which is R. R is the arbitrary point where you have X, Y, Z. A is the point you have a proper coordinate, right? Okay. Now you have to understand, because of this rotation, plane rotation, what will happen? This A becomes A prime. A becomes A prime. R becomes R prime, right? R becomes R prime. Now, I'm writing here R becomes R prime, A becomes A prime. This is after rotation. This is after rotation. Now, what do you think about your n vector? Now, suppose your n vector is here, n vector. What do you think about the n vector here? Do you think when you are rotating, n vector is changing? N vector is not changing. Like, okay, so now you can see this is n1 here. This is going to be n2 here. Right? So n vector, n1 vector, also going to be n2, n2. Rotation. Right? So now phi 1 I can write as R dot n1 is equal to a1 dot n1. Phi 2 after that's a rotated one. That should be R this suppose this is R1. Okay, so this is going to be R2. N2 is equal to A2 dot N. Now the question is, how do you find these rotations, right? So to find these rotations, we are using a rotational matrix. Use a rotational matrix to find the new transformation. This is how you do it. XYZ, that rotation in X is acting on that XYZ, then that's a rotational matrix. Then you get X1, Y1, Z1. So similarly, A and N do the same thing. Right? So that means, for example, simple example, right? So you have X. You multiply this by -5. What will happen? So it becomes now -5x, right? This is your new value. That is your X prime. X is there. When you multiply this by -5, becomes X prime. This number goes with this rotation. That is given to you. Even in the SAC exam, they will give it to you. Right? So that rotation is this. R in X theta, that matrix is 1, 0, 0, 0, cos theta minus sin theta, 0, sin theta, cos theta. This is the matrix. Right? Now we'll do a small question here, example. Consider Rx theta x is going to be X prime. So that means this is how we do it. 1, 0, 0, 0 cos minus sine, 0 sin theta cos theta. This is going to be X, Y, Z. So that means rotation is acting on XYZ. So XYZ, rotation is applied, then rotating. XYZ is here, rotation is applied, then it rotates. So when it rotates, your new coordinate is going to be X prime, Y prime, Z prime. Now, you know how to do the matrix multiplication. So this is going to be X. This is going to be Y cos theta minus Z sin theta. And this is going to be Y sin theta plus Z cos theta. And this is going to be X prime. This is going to be Y prime. This is going to be Z prime. So picture would be this. You have this original. This is after rotation. This point is X comma Y comma Z point. And this point is X prime, not X prime comma Y prime comma Z prime point. So what we did was we tried to find out a relation between this coordinate to here with the given angle theta. So now if you check this one, you can see this Y prime, which is this guy, you are writing in terms of these coordinates and the angle. That's what we do. So this question So this rotation is about x-axis. Rotation is about x-axis. So this is x over here. Now, I'm going to have a plane here. That plane is going to be pi 1. And there is a point here. This point is A. And that point is 0, 0, 5. Or maybe other way around. Because it's in the x-axis. So 5, 0, 0. That's exactly on the x-axis, that point. The scalar equation. The scalar equation of pi 1 is 2x minus y plus z is equal to 10. Question is, find the scalar equation of pi 2 after theta is equal to pi divided by 4 rotation. So now once you get the rotation, that rotation can be like this. That rotation can be like this. And this is going to be theta. And the new plane is pi 2. So you need to find pi 2. Okay. So, so you have the coordinate here. You have the coordinate here r. And that has xyz. xyz is related to that coordinate. So the same thing is here, r prime, I would say. And that would be x prime, y prime, z prime. So this x and y and z is with this point here, right? Now, you can find this n1 vector from 2, minus 1 and 1. So it's going to be 2i minus j plus k. So you find n1 from there. Now, when you rotate, your normal vector also rotate. So your normal vector, I would say n2. n2 is going to rotate. So what are the things, first of all, we will understand what are the things going to rotate. XYZ going to be x prime, y prime, z prime. Then n1 is going to rotate and gives you new n2. Right? What else going to rotate here? A is not going to rotate in this case. Why? Because A is purely on the x-axis. You got it? It's like this. I trickily give you the question. This is like this. So when you're rotating, that's the rotation. See? A fix at A there. I trickily gave you the question. Yeah. Rotation, this is x-axis. So now here, you can see n is this way, right? When you do this, n is that way. So n is changing. Your r is here. R changed. A is not going to change. N changed. Angle theta. Right? So that's all. So now you have to use the rotation matrix. What is the rotation matrix now? That would be r theta pi divided by 4. That would be 1, 0, 0. 0 cos theta, right? 1 divided by square root 2 minus 1 divided by square root 2 0, 1 divided by square root 2, 1 divided by square root 2. Like that. Now that is my r theta, right? R theta thing. So how do you find x prime, y prime, z prime? You multiply this by r theta matrix. You multiply this by r theta matrix. Then you get into. Simple. That's all you do. Simple thing. Then if you need to find pi 2, that would be R2 dot N2 is equal to A dot N2. R2 you have from here, N2 you have from here, A already known, N2 you have from here. Game over.